Okay, guys, welcome to your lecture for today. We are going to be continuing talking about the cellular organization of our body. So please go ahead and think about this as we go through your bell work questions. We are reviewing the answers from last week's bell work, and you're wanting to use the following explanations in order to correct your answers. So this is what you should be thinking about, but the actual question is coming soon. Okay, so your first Monday's bell work asked you to define site, hist, hypo, and hyper. So there are some ways that people remember. These are called medical terms or medical terminology, and it's called an audionym. So hopefully this can help you in the future. So site sounds like sight, and the visual images that you can see the site of the gun in the cell. You can see this, you can sight the cell. So cell means, so site means cell. Hist means tissue. You can see a history book's cover is made of tissue. So hist means tissue. There was no picture I could find of that one, but that is the common audionym. Hypo means beneath or below or under. So hypo sounds like hippo, and you see this hippo under the table. Hypo means under. Again, hypo sounds like hippo. You see the hippo under the table. Hypo means under. Hyper sounds like high purr. The visual image, you see a cat high purring more than usual or an excessive amount. Hyper means above or excessive. Again, hyper sounds like high purr. You see the cat purring high and more than normal or excessive volume. Hyper means above or excessive. Another part of your bell work asked you which was the most simple and which was the most complex level of organization. Cells are not the most simple. Remember, chemicals are more simple than cells, and chemicals help our body regulate homeostasis and communicate to various parts of the body. Common are elements or molecules found at the chemical level of organization. And the most complex would be organisms, because organisms, you can break them apart into many parts. That means if you were trying to simplify an organism, you would have to have so many parts to simplify an organism, making it much more complex than, for example, a chemical. Cells build tissue. So here's a picture of your skin, and it's composed of many different epithelial cells. So cells create tissues, and the cells pictured here are from your skin, and they're made of epithelial cells that make the integumentary tissue. The 11 body systems can be remembered by this mnemonic REMIND curls, where R stands for respiratory, endocrine, muscular, integumentary, nervous, digestive, circulatory, urinary, reproductive, lymphatic, and skeletal. So this is a really good way to remember all of the body systems. And just knowing a common function of each is very important for your upcoming exam. The components of feedback loop. So a receptor is going to monitor a controlled condition. It's going to monitor that stimulus if it's going above or below the set point. The control center is going to determine the next action. The effector receives the directions from the control center and then produces a response that changes the controlled condition. So we had an example of the glucagon mechanism to increase a patient's blood sugar But glucagon, even though its mechanism was to increase blood sugar, it negated the decrease in blood sugar from the original stimulus. So that made it a negative feedback loop. The only way it would be positive is if it were in the same direction as the stimulus. Okay, if you have any questions over last week's bell work, please reach out. I want you to review your answers from last week's bell work and use the explanations we just described to correct your answers. Here are the questions I want you to answer for your bell work today. What topics did you struggle with most last week? Do you understand these topics better now? And what topics do you feel you did the best on last week? Go ahead and pause your screen and answer these questions to complete today's bell work. All right, so last week we talked a little bit about concentration gradients and how the plasma membrane separates the extracellular fluid, which is a type of extracellular fluid, which could be considered interstitial fluid, right? Extracellular fluid also contains the intravascular fluid, also called plasma. So the cell membrane is going to separate the extracellular environment from the intracellular environment. And concentration gradients are formed when we have differing amounts of molecules separated by the plasma membrane. So here we have a higher concentration of molecules on the outside of the cell, or an increase in the concentration of the molecules in the extracellular environment compared to the intracellular environment, which has a lot less of these molecules. So simple diffusion is a mechanism to where molecules are going to be going towards an area of lower concentration. So molecules go from areas of high concentration to areas of low concentration when separated by a membrane. And this is going down their concentration gradient as a mechanism of simple diffusion. And here's a little picture to help you. There's the high concentration on the external environment, a low concentration on the inside. There's no carrier, there's no energy needed. It will go through simple diffusion to go to the inside of the environment. Now this only happens when this molecule is able to freely pass through the cell membrane, because not all molecules can just simply diffuse into a cell. Facilitated diffusion occurs across cell membranes as well, but it requires the help of carrier proteins or channel proteins. Channel proteins and carrier proteins are quite similar, except that channel proteins are just like an open door. And all the molecule needs to come through this channel protein is the open door. So they are less selective because channel proteins don't care what molecule is coming in, or really what the molecule is, or much more than the concentration gradient to let the molecule in or out of the cell. This still follows the rules of diffusion, where molecules are going to go down their concentration gradients from an area of high concentration to an area of low concentration, but these molecules can't just freely go past the plasma membrane and require plasma proteins, which are channel proteins or carrier proteins, to facilitate the diffusion through the plasma membrane. Carrier proteins are more selective and often only allow one specific type of molecule to cross. The way I like to think of carrier proteins is that they have a special key system, and only the molecule with the same shape as the key is permitted access through carrier proteins. Now, this still happens through facilitated diffusion, which means no energy is required, but a door is required. So the door for carrier proteins has a key. And then if the key allows entry, they will freely flow from an area of high concentration to an area of low concentration. Here is another picture of passive transport. Both facilitated diffusion and facilitated and diffusion are considered passive transport. No energy is required to move these molecules across the plasma membrane. The only driving force to the transport of these molecules is a concentration gradient, where molecules will go from areas of high concentration to areas of low concentration. The difference between diffusion and facilitated diffusion is that facilitated diffusion uses plasma proteins, such as carrier proteins or channel proteins, to allow the access of these larger molecules that will not freely pass through the plasma membrane across. They act as doors or passageways for these molecules to cross the plasma membrane. One type of diffusion that is specific is water, the diffusion of water, called osmosis. Osmosis is the diffusion of water. Now, the weird thing about diffusion is that water is going to move from areas of low solute concentration to areas of high solute concentration. Water itself is trying to dilute the concentration of molecules. So that is how osmosis works. It's the process of water diluting solutions. When a solution has a semi-permeable membrane, water will move from an area of low concentration of solutes to an area of high concentration of solutes. And you think of osmosis as the process of diluting solutions. Here is our little animation for osmosis. So you can see on the left side that there are no solutes. This is actually reverse osmosis. I'm thinking at the end the GIF will go back to osmosis. Here we go. Osmosis is where the water is going to go from areas of low solute concentration to areas of high solute concentration to dilute the solution. And here we see the water moving. Another example of osmosis is how water affects red blood cells. Red blood cells, also called erythrocytes, are filled with a certain concentration of solutes, and they're aqueous, so they also have some water in them as well. Hypertonic describes a solution in which the tone, or the concentration of solutes, is higher on the outside than the inside. And when we're talking about red blood cells, we're saying that that when a red blood cell is put in a hypertonic solution, they will shrivel up. Hypertonic solutions shrivel red blood cells or shrink them. How does this mechanism occur? Well, imagine that you have a red blood cell put into a hypertonic solution. The solution on the outside of the blood cell would have more concentration of solutes than the inside of the red blood cell. The water would exit from the red blood cell, leaving the red blood cell dry and creating a shriveled form. What we really like is isotonic solutions because they will not shrivel up our red blood cells. So when we have isotonic solution and we put red blood cells in it, there's no difference between the concentration of solutes in the solution and the concentration of solutes in the red blood cell. So there will be no movement of water because there is no diffusion osmosis necessary. We want our red blood cells to stay just in an isotonic solution. Iso means equal. Tonic refers to the tone or the concentration of solutes. So when we have an equal tone of solution compared to the red blood cell, then nothing will happen. The water won't move because there's an equal concentration on the inside of the cell and the outside of the cell. Hypotonic solutions will lyse red blood cells. Hypotonic solutions result from a lower than normal tone of solution concentration. So when you place a red blood cell in a hypotonic solution, the solution on the outside of the red blood cells concentration of ions is less than the concentration of ions within the inside of the red blood cell. Water will therefore diffuse or undergo osmosis and go from the solute concentration that is low on the outside of the cell to diffuse the concentration of solutes that is high on the inside of the cell. This results in overflooding of these red blood cells and lyses the cell or bursts or breaks the red blood cell because of the high influx of water into the red blood cell. Here are a couple of animations for you to better understand passive transport of osmosis. So here we have a hypotonic solution where this ion concentration is less on the outside of the cell than compared to the inside of the cell. So you see all of these water molecules going into the red blood cell, causing it to expand and eventually lyse or burst. Here we see that the water is not going into the cell nor leaving the cell in a faster movement. So this is representative of isotonic solution. Hypertonic solution results in the red blood cell shriveling because water leaves the red blood cell, resulting in dehydration of the red blood cell and shriveling. Next, we're talking about active transport. Active transport requires ATP. ATP is called adenosine triphosphate, and it is our energy source for our body. This is what our body can use for energy or money. It is the currency of our body. So when we are going from areas of high concentration to areas of low concentration, we sometimes still will need to have active transport because, for example, sodium is high on the outside of the cell and low on the inside of the cell, whereas potassium is high on the inside of the cell and low on the outside of the cell. But we still need to be able to allow sodium access into our cells, and we still need to allow potassium access out of our cells. We do this by using the sodium-potassium pump. Sodium-potassium pump requires sodium, ATP, and potassium to move these ions against their concentration gradients through the use of ATP. So we've talked about how passive transport results in molecules naturally moving down their concentration gradient. That is why it's passive. Active requires ATP because we are taking these ions against their concentration gradient, and we have to add energy in that to facilitate this type of transport. Here is a picture of active transport. We add ATP, and we are able to move molecules against their concentration gradients into the cell or out of the cell. Here is your exit ticket for the day. What type of solution makes red blood cells shrink or shrivel? If the concentration of solutes is greater on the inside of a red blood cell, what would you expect to happen? What is this process called? What is the major difference between simple diffusion and passive transport? Go ahead and pause your screen, complete your exit ticket, and I look forward to hearing from you all soon. Have a great rest of your day.